Hello students, how are you all? I hope you all are fine, studying all the top topics and revising all the topics thoroughly, right? So let's start with this particular session. And so far we have discussed the indirect methods, measurement of length, right? Various indirect methods for measuring large distances, small distances. In this session we'll start with concept of mass, measurement of mass, right? So, measurement of mass. Do you know, students, that mass can be measured in two ways? Mass of any given body, it can be measured in two ways. And accordingly, mass is divided into two types, depending on the way in which the mass of the body is measured. There is no doubt that mass is the amount of matter contained in the body. But depending upon the manner in which that amount of matter in the body is measured, the mass is divided into two types. One is the inertial mass, the other one is the gravitational mass. So we'll start with inertial mass. Look, inertial mass. In this term inertial mass, inertia, that's the key word, inertia. Inertia means inability of a body to do anything at its own. That is, it represents inertness of a body. Now look, if a body is at rest, it can't change its state from rest to motion at its own. Or if a body is in uniform motion, it will continue to be in uniform motion until and unless some external unbalanced forces apply to it. What I mean to say is that the inertness of a body, the measure of inertness of a body, that is basically given by inertia. Right? So, inertial mass actually gives the measure of inertness of a body. How inert a body is, that can be given by its inertial mass. Understood? So inertial mass actually it is defined as when a body is in translational motion under the influence of some external force in the absence of gravity, then the mass of the body measured will give its inertial mass, right? So the body should be in translational motion, obviously under the influence of some external force in the absence of gravity. Then the mass of the body measured is inertial mass, right? So how to calculate it? How to mathematically measure it? We are aware of the consequence of Newton's second law, isn't it? You have studied it in class 9th. We'll discuss it in kinematics as well, right? We are aware of this formula, F is equal to ma. So whenever some external unbalanced force is applied on the body, then the body gets accelerated, and the mass acceleration in the body is related by F is equal to ma. That's the relationship of force, mass and acceleration. So mass of the body, it is F by a. So the acceleration produced in the body by application of some external force. In such a case, the mass of a body measured by this particular formula will give its inertial mass. Right? So, inertial mass of a body is measured by the influence of some external force on the body and measuring the acceleration produced in the body. So in that case, the ratio of F by A, the force applied to the body divided by the acceleration produced in the body, that will give the inertial mass of the body, right? Actually, there is an instrument, or rather an arrangement, which can be used to measure inertial mass of the body. It is known as inertial balance. It is known as an inertial balance. It is known as an inertial balance. It basically consists of a long strip. One end is fixed while the other end is loaded with some body whose inertial mass is to be calculated. Now, when it is disturbed from its mean position and released, it will start executing vibratory motion. So, noting down its time period, we can easily calculate the inertial mass of a given body by using this instrument which is known as an inertial balance, right? So, students, inertial mass is measured quantitatively by this particular formula by using Newton's second law, right? F equals to ma. And when a body is in translational motion in the absence of gravity, then the mass of the body measured is known as the inertial mass, right? Next is gravitational mass. Now, as the term suggests, gravitational mass, so it should be under the influence of gravity, right? So, in the absence of motion, if the body is only and only under the influence of gravity, then the mass of the body measured is known as gravitational mass. It gives the measure of gravity actually, right? So, how to calculate it mathematically? Now look, this is Earth of mass capital M. This is a body of mass small m. The distance between them may be considered to be equal to the radius of the Earth, right? Because the dimension of the body is extremely small as compared to the dimensions of the Earth. Now we are aware of basic forces in nature. One of the basic forces is the gravitational force. So what is the gravitational force between these two? It is G capital M small m divided by R square. Now, using the concept of gravitation, the mass of a body measured using this formula, it will give us the gravitational mass of the body. Clear? The mass of a body measured by this formula will give us the gravitational mass of the body. So, any given body, its mass can be calculated by either of these two methods. Accordingly, it is either known as inertial mass or it is known as gravitational mass. And gravitational mass is measured by an instrument known as physical balance. We have seen it, we have used it as well, and it is based on the principle of levers. Physical balance, which is used to measure the gravitational mass of a body, is based on the principle of levers. And most importantly, look, both actually gives the measure of the amount of matter contained in the body. So we are talking about the same body, its amount of matter should remain constant. So what I mean to say is that the ratio of the inertial mass to the gravitational mass, the ratio of the inertial mass to the gravitational mass of a body is always equal to unity, that is 1. What it suggests is that the inertial mass of a body is exactly equal to its gravitational mass. The only difference is the way they are measured. Inertial mass is measured by making use of Newton's second law consequence, that is F equals to ma, while gravitational mass of a body is measured using the gravitational concept, that is by using this particular formula. So I hope you have understood this concept, inertial mass and gravitational mass. Now we have discussed the SI unit of mass, which is kg, which we are all aware of. There are some other units also to measure mass. In CGS, mass is measured in gram. We are aware of it. It is 10⁻³ kg, right? Then we make use of ton. It is equal to 10⁻³ kg. Then we make use of quintal. It is also a unit of mass which is used frequently. It is 100 kg. Then we make use of pound, P-O-U-N-D, pound. Students, you must remember, in the FPS system, pound is the unit which is used to measure mass. Now we need to get the relationship, or we need to be aware of the relationship between pound and kg. Actually, 1 pound is 0.454 kg, or it is 454 grams. So 1 pound is 454 grams, or 0.454 kg. Another unit is ounce, O-U-N-C, ounce. 1 ounce is about 28.3 grams. Now look, you all must have watched cricket match or in fact played cricket match. So it is played with a cricket bat and a cricket ball, isn't it? The mass of the cricket ball is about 5.5 to 6 ounce, which is about 150 to 160 grams. So there we make use of ounce. The mass of a cricket ball is about 5.5 to 6 ounce, right? So these are various different units for measuring mass. So there are some other units of time as well. If you discuss the time, other units of time, we have discussed various units of measurement of length. We have discussed various units of measurement of mass. Let's discuss various units of measurement of time. MLT. These are the three basic units. Obviously, there are 4 other units as well. So, other units of time. SI unit of time is, you're all aware, it's second. But there are various other units of time as well. Suppose a day, a week, a month, a year, cosmic year, solar year, right? Lunar day. These all are the units of time. Second, hour, minute. These all are the units of time. So, units of time are second, minute, hour, day, week, month, year, solar year, cosmic year. So these all are the units of time, right? There are some small units of time as well, like millisecond, microsecond, picosecond. 1 millisecond is 10 to the minus 3 seconds. Microsecond is 10 to the minus 6 seconds. Picosecond, it's picosecond. It is 1 microsecond, which is equal to 10 to the minus 12 seconds. Another unit of measuring time, this unit we basically make use of in nuclear physics, in chain reaction, right? So in that case we make use of this unit of shake, S-H-A-K, shake. It's the unit of time. And 1 shake is equal to 10 to the minus 8 seconds. So this is again a very important unit. So students, we have discussed various units of length, mass and time. In the subsequent chapters, we will encounter various other physical quantities and we can discuss the units as well, right? So for this lecture, we have discussed the measurement of mass. It can be done in 2 ways. And accordingly, there are 2 types of mass, inertial mass or gravitational mass. Then we have discussed how to quantitatively measure the inertial mass or gravitational mass of a body. And then a very important concept, the ratio of the inertial mass to the gravitational mass of a body is always equal to unity. And then obviously we have discussed various units of measuring other mass, quintal, pound, ounce, ton. And then we have discussed some units of time as well, right? So, I hope you have understood all these topics, right? We'll continue in the next